Hi everyone. In this video, we will be discussing rational functions for Math 1451 at Texas Tech University, which is Calculus 1. So rational functions are not something that we learn in calculus. They're something that we learn in algebra, but a lot of students struggle to know how to work with rational functions in order to be able to take the limits, derivatives, and integrals that we will do in this class. So a rational function is just a quotient of two other functions. So I'm going to go ahead and highlight that. It's a quotient of two other functions. So we're typically going to see this as a quotient of two polynomials, but sometimes we may see something a little bit different. So like I said, throughout calculus, we're going to need to simplify functions like this in order to evaluate their limit, derivative, or integral, the three kind of main topics of this course. So if you haven't gotten to these words yet, that's fine. They're just the three main topics. So how do we simplify rational functions? So the way we approach this depends on how the functions look. So sometimes we have a denominator with one or two terms, and other times our denominator has another fraction within it. So we're going to consider these three cases: when our denominator has a single term, two terms, or if our denominator has something that's a little more complicated, such as another fraction. So you may be coming to this video thinking, I'm doing everything right. I have no idea what I'm doing wrong, but I know that my problem has to do with rational functions. And I keep getting the questions wrong that have to do with these types of functions. So in this case, you may be mistakenly canceling terms that don't actually cancel. So for example, consider this rational function, x cubed minus 1 over x minus 1. So when you see this, you may think, okay, yeah, I know how to do this. I see a negative 1 on top and bottom that are going to cancel. And then I get an x cubed over x, which is x squared. So this is actually not correct. So one thing that we need to make sure is that we're only canceling division with multiplication. So we can kind of frame how we think about this. So remember that a rational function is a quotient of two other functions. And when we think quotient, we think dividing. And we know that if I'm dividing, I can only cancel that out with multiplying. So for example, if I have a question where something's divided by 2, to get rid of that, my only option is to multiply by 2. So we can only cancel division with multiplication. So I'm going to highlight that down here, because it's really, really important for us to not make mistakes when we're simplifying rationals. So what we did up here is we simplified subtraction with division, and we can't do that. We need to cancel multiplication. So because we have terms being added and subtracted in our numerator and denominator, we can't do anything to cancel these out. We need to change the subtraction into multiplication before we can cancel out. So let's look at some correct ways to simplify rational functions. So in this video, we're going to be looking at, like I said, three cases. If the denominator has a single term, two terms, and lastly, if it has a fraction within itself. So if the denominator has a single term, we can use a strategy of distributing division over addition and multiplication. So you may have heard something that sounds like this before. We often distribute multiplication, but we way less often distribute division. So what we can do here is we just break this up, and we take each term in our numerator and we divide it by that denominator. Okay, and then now that we have, this lets us basically get rid of the addition and subtraction in our numerator that we're not able to cancel out. And instead, now we have three different fractions where we're only dealing with multiplication and division. So we can cancel out this here, this x here. So we end up getting 2x plus 9 minus 4 over x. And if we want to simplify this even more to look like just powers of x's with coefficients added together, we can write this as 2x plus 9 minus 4x to the negative 1. So this last step is not essential. It depends on what we're going to use this for. So if we were using this to evaluate a limit, we would likely keep it in a fraction. If we were trying to take the derivative, we would likely put it in that x to the negative 1 form. And if we were taking an integral, we would likely leave it as 4 over x. So either of these two is good. So like I said, it depends on if we're going to take a limit, derivative, or integral, depends on what form we would like it to be in. And your instructor may have more specific instructions about what they would like you to do with this simplification. So next, if the denominator has two terms, one option is to factor the numerator and denominator to find common terms. So for example, consider the same function that we looked at and read up here, and we're going to talk about the correct way to simplify this. So this correct way is going to come through factoring. So depending on how much you remember factoring strategies from your high school courses, you may immediately say, okay, I know that this is a difference of cubes, so I can factor like so. So when I said here, this is a difference of cubes. And depending on your instructor, you may have reviewed difference of cubes, difference of squares, things like that, these different factoring strategies at the beginning of your calculus course. And if you didn't, that's fine. It just may be a little bit more responsibility on you to remember these different factoring strategies from high school, because we can see that this numerator is x cubed minus 1 cubed, which factors as x minus 1 and then x squared plus x plus 1. And we can see that these x minus 1s are going to cancel out to give us x squared plus x plus 1. So again, this is a strategy that's useful if you remember those different factoring strategies from high school algebra. However, if you don't remember those strategies from high school algebra, we also have a second option. And our second option is to perform polynomial long division, or another option here is synthetic division. So depending on your experience with pre-calculus, this is typically when students learn long division and synthetic division, and a lot of people preference synthetic division. I'm going to here show you polynomial long division just because it's what you use more in these upper division math courses. So we can find this exact same simplification obtained by dividing. So, like I said, we're thinking about these rational expressions as quotients. So I'm going to take my numerator divided by my denominator, right? This is typically how our division problems work. Okay, so what we're going to do now is we're just going to focus on this front term of the x cubed and the x. And we're going to make sure that because we're just focusing on these first terms, we're going to write this with the highest power of x in the front. So all we're going to do is divide these two things. So x cubed divided by x is x squared. And then we just proceed like normal with long division. So we subtract x squared times our divisor of x minus 1. And so I'm going to just write this out fully by carrying down my x cubed minus 1. And then I'm going to go ahead and distribute to get negative x cubed plus x squared. And then I can cancel these things out. So again, remember, we're just going to write our highest power of x in front. So we get x squared minus 1. And again, now I'm just doing x squared divided by x, which is positive x. And I subtract x times my divisor of x minus 1. Again, I'm going to carry everything down. My x squareds are going to cancel. And I'm going to rewrite this with my highest power of x in front. And now I just do x divided by x, which is 1. And then I'm just going to subtract this, which gives me 0. So when we do our division in this way, we see that we're going to get x squared plus x plus 1. And this all just came from the highlighted parts where we're just taking the highest power of x and dividing it by our x from x minus 1. So if you prefer synthetic division, that's another way to do this. But polynomial long division, like I said, is going to be used more in math courses later on, which is why we're talking about it here. And our last form of the denominator is if our denominator is a rational expression. Then we're dealing with a so-called complex rational function, which just means we have fractions within fractions. So to simplify this type of expression, we simplify the numerator and denominator separately, and then we're going to divide those results. So What I mean by simplifying the numerator and denominator separately is I'm actually going to, just like before, this entire process has been, we want to get rid of the addition and subtraction in the numerator and denominator so that I can actually multiply and divide. So to do that, we just need to do that addition. So my common denominator in my top is going to be x, and my common denominator in my new denominator is going to be x as well. So we just change everything to be fractions with common denominators, and then we have x plus 1 over x divided by 3x minus 1 over x. And now we have transformed this into just dividing two fractions. And we know that whenever we divide two fractions, all we're going to do is flip the second fraction and multiply. And we can see that this x is going to cancel out, which is just going to leave us with x plus 1 divided by 3x minus 1. And this is all we can do here. So all we can do here is figure out what this rational expression should be that doesn't have fractions within our fraction. And then from here we can try and do this division, but there's not going to be any common way that this is going to factor out, in particular because our x's have the same power, that it's going to be easier in most cases to just leave this here. So like I said, a lot of this is going to be things that you've seen before in high school algebra, but you may not have remembered, or you may not have been taught the same ways to do it that we're going to do them here at Texas Tech. So if your denominator looks different ways, we have different ways to simplify it, like you can see. But the biggest takeaway from this is that we're going to remember that a rational function is a quotient of other functions, and we can only cancel out that division with multiplication because it is a quotient, which means division. So that's how we're going to approach simplifying rational expressions. So we hope this helps, and good luck.